I hope you are enjoying these lectures and you are following the daily schedule and practicing the daily practice problem that has been given to you. So we are in the middle of a very important chapter, that is solutions. Okay, if you see the JEE advanced paper or the mains paper, there is definitely one question coming from this chapter. So if you see the last 7-8 years papers, so there is definitely one question every year that is being asked from solution chapter. So from that you can guess the gravity of this chapter. This chapter is of immense importance for JEE prepared for the JEE aspirants. Okay, so we were discussing about the Van't Hoff factor in the previous lecture. So we just started the foundation, or we just introduced the idea of Van't Hoff factor. So today we are going to build more concepts on this and we are going to do the problem solving. So in today's lecture we will be focusing only on Van't Hoff factor and we'll solving a lot of questions. And in the next lecture, that is on Monday, we will be solving some tough level problems. We'll also see how JEE advanced questions are and like what kind of questions are coming in JEE advanced, some objective question, some subjective question. Basically the problem level would be little tougher than what we are doing in the class. Okay, so if you are following now the chemistry program judicially, so you will understand that we are starting the chapter right from the basics. Okay, so we start right from the basic, from the level of NCERT. We keep on building the concept, we keep on solving some subjective level problem to make us understand that concept. And if after the class you are solving the daily practice problem sheet, that would be enough for anyone to crack JEE with a good marks. So you have to just follow the pattern, follow the chapter which has been instructed to you at this platform, and believe me, even if you can't see much of a change right now, after 2 or 3 months you will see a lot of change that has developed inside you. Okay, so I have already told everyone that this is a preparation for the concepts. This is the preparation for increasing your skill set. This is not just a preparation to get the marks or chasing a college or chasing the top positions. Okay, so this is basically about understanding yourself, increasing your willpower, increasing your skill set, and then working and enjoying the process. If you are thorough with all those things, then definitely good result is bound to come. So just don't run after the results, just enjoy the process. When you are doing one chapter, just feel connected to the chapter, enjoy the process of learning, enjoy the process of reading, enjoy the process of writing. I know some of you might be facing problem in writing your notes or creating the notes during the classroom program. So what I would suggest to you, whenever there is a question coming on the board, okay, whenever there is a question coming on the board, you can pause. Okay, you can just pause. Okay, you can see the question, you can solve the question, and then you can again replay. The lecture would start from that point only. Even though it is a live lecture, but we have a special DVR facility where you can stop the lecture in between. Okay, you can do the problem solving by your own and then you can play the lecture. So it will play in sync, like from where you have stopped. Okay, so let us start with the concept of Van't Hoff factor. Okay, so we have introduced the Van't Hoff factor. In the previous lecture we have told that if we are taking a electrolytic solute, till now we were just adding a non-electrolytic, non-volatile solute. Now suppose we add an electrolytic solute in a solution. So we know that the electrolytic solute would dissociate into ions or associate, and the number of particles in the solution would change. Okay, suppose we were adding NaCl, we had added only one particle. Okay, that was one NaCl. But when NaCl went into the aqueous solution, it dissociated and gave us 2 ions. So the number of particles in the solution increased. So the colligative property would correspondingly change, because colligative property depends upon the number of particles rather than the nature of particle. Similarly, if the solute associated, so the number of particles would decrease and hence the colligative property would also decrease. So we have to take care of this fact that solutes can be electrolytic as well. So the Van't Hoff factor, or I, which we introduced in the previous lecture, will take care of the electrolytic solutes. Okay, so we defined I as the total number of particles finally upon initial number of particles, right? That's how we dealt, that's what we dealt in the previous lecture, and we did some basic level problems, okay, finding out the Van't Hoff factor for an association or a dissociation reaction. For association reaction, we could easily make out that Van't Hoff factor was less than 1, whereas for a dissociation reaction, Van't Hoff factor was always greater than 1. Okay, so we'll define colligative property as the observed colligative property upon the calculated or the theoretical colligative property. Okay, so whenever this word observe comes, observation is basically carried out in laboratories. Okay, observation means experimental. We are observing something. So observation is always made in during the experiments. So this is basically observed colligative property divided by calculated colligative property. Okay, so I can say that I is equals to, okay, I can say that I is equals to, okay, if suppose delta TF is the observed, okay, is the observed depression in freezing point, okay, when we are doing the experimental analysis, okay, and we know that delta TF, okay, theoretical, okay, which is Kf into M. So I can write delta TF as I into theoretical or the calculated colligative property, which is Kf into M. Okay, so we'll always incorporate a Van't Hoff factor. Okay, so basically we are incorporating a Van't Hoff factor in the expression. Similarly, I can also write I as, okay, another colligative property is elevation in boiling point. So the elevation in boiling point, that is observed or experimentally, divided by the theoretical, okay, elevation in boiling point. Okay, so this is delta TB is the observed colligative property when a electrolytic solute is added to a solution, and this is the theoretical one. Okay, so theoretical one doesn't take care of the fact that the solute can be electrolytic. Okay, so it does not take care of the Van't Hoff factor. Okay, so the delta TB in this case would become I KB into M. Similarly, you can write, okay, I can also be written as osmotic pressure that is obtained through experiment or observed divided by osmotic pressure that is observed, that is calculated, okay, or the theoretical one. So I can write, we know that theoretical osmotic pressure is C into R into T, so pi would be I into C into R into T. Okay, so all the expressions would be incorporating the Van't Hoff factor or the I over here. Okay, so hope this is clear to you. So I can directly write that, okay, this I have already told you in the previous lecture. We can directly say that the relative lowering in wear pressure was P naught minus P upon P naught. This will be equal to mole fraction of solute into the Van't Hoff factor. Okay, similarly I can also write delta TB is equals to I KB into M. I can write delta TF equals to I KF into M. We can also write osmotic pressure is equal to I into C into R into T. So we will be taking care of the fact that solutes can be electrolytic as well. If solute is not electrolytic, it is a normal non-electrolytic solute, then Van't Hoff factor value would be 1. So we will be getting the expression which we have already derived. Okay, if it is electrolytic in nature, then we have to incorporate its Van't Hoff factor because the number of particles in solution will change. Okay, so I will write I as observed colligative property upon calculated colligative property. Now I can also be written as normal molar mass or molecular mass. Normal is your calculated one, okay, divided by abnormal or the observed molecular mass. Now this also I have already told you. Now suppose you are taking acetic acid. You are adding acetic acid in a non-polar solvent. Okay, now we know that acetic acid being acid will ionize only in aqueous solution. So it cannot ionize in aqueous in a non-polar solvent. Okay, so acetic acid will not be able to polarize in a non-polar solvent. So what it will do, it will go in the solution and get associated. Two molecules would get associated and form a dimer. So eventually that would behave as one molecule. So molar mass of that would be twice of the original molar mass. Okay, so this is your experimental molar mass because this is what you are getting from your experiments, because what we are expecting that we are mixing acetic acid, okay, in a solution. So we know its molar mass, that is our theoretical molar mass or the normal molar mass. When it is going inside the solution, it is getting associated. Okay, how we will come to know that it is getting associated? It can be verified only through experiments. So that would be our observed molecular mass or the abnormal molecular mass. So Van't Hoff factor is basically normal molar mass or molecular mass divided by abnormal molecular mass, or we can also say it as calculated molar mass or molecular mass divided by observed molecular mass. So they are just opposite to each other. Okay, Van't Hoff factor was observed upon calculated colligative property, whereas in terms of molar mass it is calculated upon observed molar mass. Okay, and the third one, which you have already done in the previous lecture, that is actual number of particles in solution, okay, divided by number of particles taken initially. Okay, hope this is clear to you. So you can take a snapshot of this. So now this is the formula that we are going to use, okay, whenever we are talking about Van't Hoff factor. So you can quickly take a snapshot or write it quickly. Okay, so let us start with some problem solving to understand the concept of Van't Hoff factor. So now there is a question that says compare the colligative properties. That means we have to compare all the colligative property of these four solutions A, B, C, D. A is your 0.1 mole glucose, okay. B is your 0.1 mole NaCl solution. C is your 0.1 molar calcium chloride solution. D is your 0.1 molar aluminum sulfate solution. Okay, so we have to calculate the Van't Hoff factor for them. Okay, now because sodium chloride, calcium chloride and aluminum sulfate are ionic solute, so they will ionize in solution. Now degree of dissociation has not been given. Okay, it is not written like it is 50% or 80% dissociated. So we'll assume that all the electrolytic solute are dissociating completely. So when NaCl will dissociate, it will give two particles. So Van't Hoff factor of this would be 2. Similarly, calcium chloride, if it dissociates completely, it will give 3 ions finally. Okay, so the Van't Hoff factor of this would be 3. Similarly, if you take aluminum sulfate, it will go in aqueous solution and it will break into 5 ions. So Van't Hoff factor of this would be 5. Okay, now when you consider glucose, glucose is a covalent molecule. Okay, so covalent molecules does not ionize in aqueous solution. So it will be present only as one unit. So Van't Hoff factor of this would be 1. Okay, so through this we have first calculated the Van't Hoff factor. Now let us consider the first colligative property, that was relative lowering in vapor pressure. Okay, now we know that relative lowering in vapor pressure is a colligative property. So more is the number of particles in the solution, okay, more would be the lowering in vapor pressure. Okay, so the lowering in vapor pressure would be maximum for D, okay, because it has the maximum number of particles, solute particles, followed by C, followed by B, followed by A. So if you want to write in terms of vapor pressure over the solution, okay, so which of the following solution will have the maximum vapor pressure over the solution? That is A, because the number of solute particle is least in that case. Okay, so the surface would be occupied by solute because number of solute particle is less, so the number of solvent particles at the surface of the liquid would be more, and hence more solvent can escape out and the vapor pressure would be more. Okay, so A would have the maximum vapor pressure and D would have the minimum vapor pressure, because the number of solute particle is 5, number of solute particle has increased. Okay, so surface will be occupied by solute, so the number of solvent in the at the surface would decrease, therefore vapor pressure would decrease. Okay, the second is the elevation in boiling point. Okay, now we know that elevation in boiling point is also a colligative property. Okay, so more is the number of solute particles, lesser would be the vapor pressure of the solution. So we have to heat that solution more so that the vapor pressure of that solution becomes equal to the atmospheric pressure. Okay, so we know that the solution which is having the least vapor pressure, okay, will have the maximum boiling point. Okay, and the solution which is having the highest vapor pressure would have the least boiling point. Okay, this is basic idea which we have already done now. So if we consider elevation in boiling point, okay, so elevation in boiling point would be maximum for D, because again the Van't Hoff factor is maximum for D, number of solute particle is maximum for D. Okay, so the vapor pressure is least for D. So the elevation in boiling point would be maximum for D, followed by C, B and then A. Now if you consider the boiling point order, okay, so obviously D has the maximum boiling point, followed by C, followed by B, followed by A. Hope this is clear to everyone. Third property which we can find out is the depression in freezing point. Okay, now we know that more is the number of particles, because it is a colligative property, more would be the depression in the freezing point. Okay, so the freezing point of aluminum sulfate would be most depressed because the number of solute particle is more. Okay, Van't Hoff factor is also high, so we'll say that the depression in freezing point is maximum for D, followed by C, followed by B, followed by A. Now if we want to arrange in terms of freezing point of the solution, okay, so the depression in freezing point of D is maximum, that is D will freeze at a very low temperature. Okay, so the maximum freezing point would be of A, because A depression freezing point is least. Okay, so it has depressed to a very small extent, so the freezing point of that solution would be highest. Okay, so freezing point of A would be greater than B, greater than C, greater than D. Okay, similarly we can find out the osmotic pressure. Okay, now we know that osmotic pressure is again a colligative property. So more is the number of solute particle, or more is the number of particle, more would be the osmotic pressure. So clearly I can say that osmotic pressure of solution D would be more than that of C, than that of B, than that of A. Okay, so hope this is clear to everyone. So this is a very basic question that is often asked. Now sometimes question like this can also be asked. Suppose you have to consider 0.02 molar NaCl. Okay, suppose this is first option, 0.1 molar glucose solution, okay, and say 0.01 molar say aluminum chloride solution. Okay, assuming all like aluminum chloride and NaCl is completely ionic in nature, so question can be arranged them according to their osmotic pressure. Okay, so this is again a very good question, so we have to arrange them in terms of osmotic pressure. Now here we will not say directly that the one which is having maximum number of particle will have maximum colligative property, because it also depends upon the initial number of particles. Okay, so we have to take care of that fact as well. Okay, in this case all the concentrations were same, so we are not looking at the concentration, we were just saying that the substance which is giving maximum number of ions, okay, the substance which is giving maximum number of ions will have the maximum colligative property. But in this case you can see that there is a difference in concentration, so you have to take care of the concentration term as well. Okay, because initial concentration will give us the initial number of particles. Okay, so from initial number of particles you have to see what is the final number of particle. Okay, so we know that osmotic pressure is I into C into R into T. R and T are constant, okay, at a given temperature. R is a gas constant, so osmotic pressure is proportional to I into C. C is the concentration. So we know that the Van't Hoff factor of NaCl is 2, for glucose it is 1, for aluminum chloride it is 4. Okay, so if you multiply I into C, so this will come out to be 0.04, this will come out to be 0.1, and this will come out to be 0.04. Okay, so you can see that in the B case the product of I into C is maximum. Okay, so osmotic pressure of solution 2 would be maximum and 1 and 3 would be equal. So it is just not that only ionic solutes will have the maximum colligative property. Okay, it can also have, as in this case, the second one which was not a electrolytic solute, still it is having the maximum colligative property, because we have to consider the initial number of particles as well. Okay, so when initial number of particles are same or the concentration is same, then we have to look for the Van't Hoff factor. But if initial concentrations are different, so you have to look for the concentration into the product of Van't Hoff factor. Okay, hope this is clear to everyone. So this is again a very basic question. Almost like every year or every 2 years, such kind of questions are asked in JEE Mains or BITSAT. You will find many of these types of questions in a given book or a booklet of any institute. Okay, so hope you have understood this well now. You can take a snapshot. Okay, chalo, let's look to the next question. Okay, this says that an m by 10, okay, or a decimolar solution, decimolar means 0.1 molar, okay, an m/10 solution of potassium ferrocyanide, okay, potassium ferrocyanide is K4FeCN6, okay. So we have been given a m/10 molar solution of potassium ferrocyanide is 46% dissociated at 300 Kelvin. What will be its osmotic pressure? Okay, so we can clearly understand that we have taken water and we have added potassium ferrocyanide in it. Now potassium ferrocyanide is having a degree of dissociation 46%. Okay, so we have to first calculate the Van't Hoff factor, and we know that osmotic pressure is I into C into R into T. Okay, so we know the concentration, which is 0.1. Okay, if we want to calculate the osmotic pressure in atm, we'll take this as 0.0821. Temperature is already given as 300. Okay, so you can also write this as, we have already told you can write this as 1/12 also, approximately 0.082 is equal to 1/12. 0.1 into 300 would be 30. So pi would be, osmotic pressure would be 2.5 into I. So basically we have to find I, okay, the Van't Hoff factor for potassium ferrocyanide. Okay, so we'll write this K4FeCN6. Now this is a coordination compound. Okay, I have already told you in the previous lecture, whatever is written in the square bracket does not ionize, comes as it is in the aqueous solution. Only the ion, okay, outside that square bracket ionizes. So we know that there are 4 potassium over here. Okay, so they will ionize and we'll get 4K plus FeCN6 4 negative. Okay, so K4FeCN6 gives us 4K plus FeCN6 4 negative. Okay, so let the number of particles initially be n, because when we'll take the ratio of final particle upon initial particle, so this n will anyway get cancelled out. So you can take any assumption. Okay, so at time t is equals to 0, let the number of particles be n. Okay, let alpha be the degree of dissociation. So we know that n alpha would dissociate, left over would be n minus n alpha. So n minus n alpha is left. Now 1 mole of K4FeCN6 is giving 4 moles of K plus. So n alpha moles would give 4n alpha moles of K plus. 1 mole of K4FeCN6 is giving FeCN6 4 negative. So n alpha will give n alpha over here. Okay, so the total number of particles finally, okay, summation n means total number of moles of particle finally would be n minus n alpha plus 4n alpha plus n alpha. So this n alpha gets cancelled out. So we'll get this as n. We have taken n as common. So n into 1 plus 4 alpha. So Van't Hoff factor we know is final number of particles upon initial number of particles. So again n will get cancelled out. So Van't Hoff factor in this case is 1 plus 4 alpha. Okay, we also know the value of alpha as, okay, alpha is given to us as 46% mean 0.46. Okay, so I can calculate the value of I, which would be 1 plus 4 into 0.46. Okay, hope this is clear to everyone. So this is 1 plus 1.84. Okay, so I would be 2.84. So you just have to plug this value, we'll get the osmotic pressure. So osmotic pressure would be 2.5 into 2.84 atm. Okay, not at all difficult. Just you have to calculate that value of I. Okay, you can look at the process. It's a very simple process. Okay, simple formula is being used. So you can see the questions are not difficult at all. Only it requires a step-by-step approach and a calculation. Okay, that will give you the right answer. Okay, hope this is clear to everyone. You can have a look at this question now. Okay, you can clearly see that if you solve a lot of good questions, basically subjective questions in the start, and when the chapter is over, you will be like, almost if you look at the chapters, almost in every chapter, in every lecture, we are doing somewhere around 5 to 6 subjective questions. So if a lecture is like 9 to 10, chapter is a 9 to 10 lectures chapter, so you will be solving at least 50 to 60 questions, subjective questions. And what I also give in the daily practice problem sheet is every day you are getting 4-5 subjective questions as well. So I will make sure that you are solving at least 100 to 120 subjective questions. Subjective questions help you in building the concepts. Okay, objective questions are basically a very simple conceptual approach question that has to be solved very quickly. Only through subjective questions you will get to learn the right concept and approach towards the chapter. Okay, so hope you are following it now. Okay, so let us look at this question. This says that calculate the amount of NaCl which must be added to 100 gram of water so that freezing point is depressed by 2 Kelvin. Kf is given of water as 1.86 Kelvin kg per mole. Okay, so we have to find the amount of NaCl. Okay, so basically this is a question of depression in freezing point. So we know that delta Tf is I Kf into m. Okay, now depression is delta Tf is given as 2. Okay, I is not given over here. Okay, so we'll say that we have added NaCl. Its degree of dissociation is not given. We'll assume it is a strong electrolyte, and actually it is a strong electrolyte only. But in case if degree of dissociation not written, we'll always assume the substance to dissociate into 2 ions. Okay, or in this case we are saying that its degree of dissociation is 1. So NaCl will dissociate to give 2 particles. So Van't Hoff factor of this would be 2. Okay, Kf we know would be 1.86. Molality we know is the number of moles of solute. Okay, number of moles of solute divided by volume of solution in this is molality, number of moles of solute upon mass of solvent in kg. So mass of solvent in kg would be 0.1. Okay, because 100 gram of water is given. So number of moles of NaCl would be 0.1 upon 1.86. Okay, so number of moles of NaCl would be mass of NaCl divided by molar mass of NaCl. Molar mass of NaCl we know is 58.5. This would be equal to 0.1 upon 1.86. So mass of NaCl in this case would be 5.85 upon 1.86 grams. Okay, hope this is clear to you now. Again, a very basic level question. So just we are using the basic logic of Van't Hoff factor and we are solving it. Okay, so you can have a look at this question now. Okay, now just try this question. I will give you 1 minute now for this question. You can try this question. This says that there is a 0.025 molar solution of a monobasic acid which has a freezing point of minus 0.06 degrees Celsius. We have to find the Ka or the pKa of the acid. Kf for water is given as 1.86. Okay, so this is a monobasic acid and we need to find Ka. Ka is generally acid dissociation constant. Already we have discussed in the ionic equilibrium. Okay, so acid dissociation constant is generally written for a weak acid. So this is a weak acid. This monobasic acid is a weak acid. So we will not say that its Van't Hoff factor is 2. Okay, because it is a weak acid, so it will be 1 plus alpha. So that you have to also derive. Okay, so monobasic acid. Let us assume the monobasic acid is Ha. Because it is written monobasic, it means it will furnish only one H plus ion in the solution. Okay, so let the acid be Ha. It will ionize in solution as H plus and A negative. Okay, let the number of particles at time t equals to 0 of Ha be n. Alpha is the degree of dissociation. So after time t, the number of moles of Ha would be n minus L alpha. 1 mole of Ha gives us 1 mole of H plus. So n alpha mole would give n alpha of H plus. 1 mole of Ha gives 1 mole of A negative. So n alpha moles would give n alpha moles of A negative. So total number of particles finally, okay, would be, because in the final solution HA, H plus and A negative all are present. So it would be N plus N alpha. I can write this as N into 1 plus alpha. So Van't Hoff factor of this would be total number of particles finally divided by total number of particles initially. So this would be 1 plus alpha. Okay, so Van't Hoff factor of this weak monobasic acid is 1 plus alpha. Now we know that we have taken this monobasic acid and we have the freezing point of the solution is minus 0.06 degrees Celsius. So depression in freezing point is, because initially we had water, we have added this monobasic acid into it. So water, we know the freezing point is 0 degrees Celsius. Okay, and the freezing point of the solution is now 0.06. So depression in freezing point would be 0.06 degrees Celsius. Okay, now we know that this is equal to I into Kf into M. Okay, so this is 0.06. I we know is as 1 plus alpha. Now Kf is 1.86. Molality is given to us as 0.025. So we can get the value of 1 plus alpha over here. So this would be 0.06 divided by 0.025 into 1.86. Okay, you can just calculate this now. Hope this is clear to you. Look, if I calculate this, this would be this comes as 1.29. So 1 plus alpha comes out to be 1.29. So alpha in this case is 0.29. Okay, so degree of dissociation of this is 0.29. Okay, hope this is clear to you. So we have got the degree of dissociation of this acid. Okay, now we need to find the value of Ka. Okay, now because this is a dilute solution, I have already told you when we started with solution. For dilute solution, we generally assume that molarity is equal to molality. Okay, because density is not given to us, so we will not be able to calculate the molarity. So we'll assume that molality is equal to molality. But don't worry, in IIT questions it is written over there. So we'll assume that molarity is equals to molality. So we now know that HA is dissociating into H plus and A negative. Okay, at time t is equals to 0, the initial concentration is C. Okay, after time t, the concentration would be C minus C alpha. Now 1 mole of HA is giving 1 mole of H plus. So C alpha that reacted would give us C alpha H plus, 1 mole of HA gave 1 mole of A negative. So C alpha that reacted would give us C alpha, okay, concentration of A negative. So this is C is basically your concentration. Now we know that Ka is equal to C alpha into C alpha upon C minus C alpha, concentration of H plus raised to power the stoichiometry into concentration of A negative raised to power its stoichiometry divided by concentration of HA. Okay, so these value we know, so the K we can write as C alpha square upon 1 minus alpha. Now we have the value of C as 0.025, okay, and alpha we know as 0.29. We cannot neglect 1 minus alpha, okay, as 1, because 1 minus alpha would be a considerable value over here, okay, because alpha is 0.29, approximately 0.3. So 1 minus alpha is 0.7. Okay, so this is C alpha square upon 1 minus alpha. So you have to plug these value, you will get the value of Ka, and pKa you know is minus log of Ka. Okay, hope this is clear to you now. Okay, so this is the process that is required to solve this question. Now when you solve a subjective question, you tend to write it step by step. Now when you are writing step by step, then entire concept of the chapter gets revised. Okay, and the process of solving a question becomes easy. So when you get an objective question, you easily solve it. Okay, so just go by this method, solve subjective question first and then enter into the objective phase. Do not start your preparation with objective question, else you will land up nowhere. Because if the question comes difficult, then you won't understand the step where you have to start the question. Okay. Hope this is clear to everyone. Okay. For problem solving in each of the lecture, I'm just saying this. Whenever a question comes on the board, you can pause you can pause that at that particular time, and you can solve that by your own, taking your own time. Okay. Once you have done it, or if you're not able to do it, then you can play the video again. So the video will start from the point where you have paused. Okay. So that would be much more helpful during the problem solving. Okay. Hope this is clear to everyone. So hope you understood each and every step written over here. Okay. So look at this question again, good level question. So this says that freezing point of a solution that contains 0.3 gram of acetic acid in 43 gram of benzene reduces by 0.3 degrees Celsius. Okay. Calculate the Van't Hoff factor. Okay. So here I think data is missing because we would need the data for benzene. Okay. The data of Kf for benzene. Let us look at if in any question Kf of benzene is there. Okay. So we don't have the value of Kf of benzene. Okay. So we'll assume any value. Okay. I will just show you the steps. Okay. So it says that when we are taking acetic acid in 43 gram of benzene. Now benzene we know is a non-polar solvent. So obviously acetic acid would dimerize in it. So we have to find the Van't Hoff factor. So obviously the Van't Hoff factor would be less than 1 because it is a dimerization reaction. So we know that delta Tf equals to Kf into IKF into M. Okay. So first we will find the molality of the given solution. So molality of this solution would be number of moles of solute. Okay, number of moles of acetic acid, because acetic acid is the solute in this case, divided by mass of solvent, benzene is the solvent, in kg. Okay, hope this is clear to you. Now number of moles is mass of acetic acid upon molar mass. So acetic acid mass is 0.3. Okay, the molar mass of acetic acid is, right, there are 2 carbons, so this is 24, 36, 32, 56 plus 4, 60. So the molar mass of acetic acid is 60 divided by mass of benzene in kg. So this would be 43 into 10 raised to minus 3. Okay, so we can find the molality as 0.3 into 10 raised to power plus 3 divided by 43 into 60. Okay, so we'll get the molality as 300 divided by 43 into 60. Okay, now this will cancel out 5, so molality is 5 upon 43. Okay, so we know that delta Tf is equals to IKF into M. Delta Tf is 0.3. Okay, I we have to calculate. Now Kf is not known to us. Okay, so this is 5 by 43. Okay, so Kf of benzene, let us assume some value so that it becomes easy. So that Kf is say 3. Okay, so Kf is 3 in this case. So we'll get the value of I as 0.3 into 43 divided by 15. Okay, hope this is clear to you. Now you can clearly see that this is round about 43. You can take it as 45. So 45 by 15 is 3. So 3 into 0.3 would be 0.9. So we'll get the value less than 0.9 over here. Okay, Van't Hoff factor is less than 1 because it's a dimerization reaction. Now suppose in this question you have been asked, find the percentage of dimerization. Okay, so we'll calculate the percentage of dimerization by expressing the Van't Hoff factor in terms of degree of association. Okay, so at time t is equals to 0, let us assume that the number of moles of acetic acid is n. Let alpha be the degree of dissociation. So we know that n alpha would associate. Okay, so let alpha be the degree of association. So n alpha would associate. So the leftover particle would be n minus n alpha. 2 moles of this is forming 1 mole of this. So n alpha would form n alpha by 2. Okay, 2 moles of acetic acid form 1 mole of dimer. So 1 mole of acetic acid would form half mole of dimer. So n alpha would form n alpha by 2. So Van't Hoff factor in this case would be total number of particles finally would be n minus n alpha plus n alpha by 2. So this would be n minus n alpha by 2 Okay, Van't Hoff factor would be final number of particles divided by initial number of particles. Initial number of particles was n, so n will cancel out. We will get the value of I as this. So you can calculate the value of I from here. So I is equals to 1 minus alpha by 2. So you will get the value of alpha. Okay, so alpha is the degree of association over here. If you multiply it with 100, you will get the percentage association. Okay, hope this is clear to everyone. Okay, just have a look at these questions. So they are not difficult, only structuring of the concept and writing it down properly step by step and then calculating is the key over here. Okay, so it's an easy chapter, solutions is an easy chapter, not difficult at all. You need to focus, you need to do a lot of problem solving on this. Okay, so all these steps are very easy. Now just solve this question. Now this is a good question. Okay, this is a question that can be definitely asked in IIT. Okay, so this says that the freezing point of a 0.08 molar solution of NaHSO4 is minus 0.72 degrees Celsius. Calculate the dissociation constant for the reaction. This was the reaction. So we have to find out the dissociation constant of this reaction. Okay, Kf of water is 1.86 Kelvin kg per mole. Okay, so just try to solve this. I will give you 1 minute. Just try to think on the process, the steps that will be incorporated over here. Okay, so first we need to find the Van't Hoff factor for NaHSO4. Now we know that, okay, I will just do it like that is the key process in this question. Okay, so NaHSO4, we know that because it is a compound of sodium, okay, it is a compound of a metal. Okay, metal generally forms a ionic bond with the non-metal. So this would break into Na plus and HSO4 negative. Okay, because it is a ionic compound, so it would break completely. Okay, so suppose this is initial number of particles say is n, so this has completely dissociated, so this will not exist in solution. N moles of Na plus would come in the solution and n moles of HSO4 negative would come in the solution. Okay, now this HSO4 negative will dissociate again because it is having a H plus ion which is acidic in nature. So this will break into this. Okay, so we need to find the equilibrium constant for this reaction only. Okay, so obviously this would be taking place in this case. So initial number of particles of HSO4 negative is n. Let alpha be the degree of dissociation. So n alpha would dissociate. The leftover particles would be n minus n alpha. 1 mole of HSO4 negative is forming 1 mole of H plus and 1 mole of sulfate ion. So n alpha moles that reacted would form n alpha moles of H plus and n alpha moles of sulfate ion. Okay, so total number of particles finally. Okay, now in the final solution, what particles are present? Na plus is present. Okay, Na plus is present. HSO4 negative would be present. Okay, this is some leftover HSO4 negative would be present. H plus is present and sulfate ion is also present. Okay, so total number of particles finally, I can write number of Na plus was n. Okay, HSO4 negative is n minus n alpha. H plus is n alpha, sulfate is n alpha. So you can clearly see they will cancel out. So total number of particles would be 2n plus n alpha. Okay, so Van't Hoff factor we know would be total number of particles finally divided by initial number of particles. Initial number of particles was n. So this would be n would get cancelled out 2 plus alpha. Okay, so Van't Hoff factor of this would be 2 plus alpha. Okay, hope this is clear to you. Now freezing point of this solution was given to us as minus 0.72. Okay, so depression in freezing point would be, initially we were having water whose freezing point is 0 degree Celsius. We added this NaHSO4 and its freezing point became minus 0.372. So depression in freezing point would be 0 minus minus 0.372. Okay, so delta TF would become 0.372. Okay, now we know that delta TF is equals to IKF into M. Okay, so delta TF was 0.372, I was 2 plus alpha, KF we know is 1.86, molality is 8 into 10 raised to minus 2. Okay, hope these steps are clear to you. So just if you write this over, this will get cancelled out. This is 0.2. If you take that over here, so this is 20 by 8 equals to 2 plus alpha. Okay, 20 by 8 is 2.5. So alpha in this case is 0.5. Okay, hope this is clear to everyone now. So we got the value of alpha. Okay, so this is a brilliant question. I will not call it as a very difficult or a very tough level problem. The only art was understanding the Van't Hoff factor. Rest all the processes are same which we are doing for each questions. Okay, so we got the value of alpha. So at time t is equals to 0. Okay, we knew that this is having 0.08 molar solution. So we'll assume molality equals to molarity. So initially 0.08 molar solution was present. This would dissociate completely. We'll get 0.08 molar Na plus and 0.08 molar HSO4 negative. So initial concentration, let us assume it to be C, which is 0.08. Okay. After say some time t, okay, the concentration would be C minus C alpha. Alpha is the degree of dissociation. Okay. 1 mole of this is giving 1 mole of H plus, 1 mole of this is giving 1 mole of sulfate ion. So C alpha, amount of H plus and sulfate would be formed. So K of this reaction would become C alpha into C alpha upon C1 minus alpha. So this would be C alpha square upon 1 minus alpha. Okay, alpha we have already calculated as 0.5. So C we know is 8 into 10 raised to minus 2. Okay, alpha we know is 0.5. So 0.5 into 0.5. Okay, and 1 minus alpha would also be 0.5. So this get cancelled out. So this is 4 into 10 raised to minus 2. Okay, so the answer of this would be 4 into 10 raised to minus 2. So you can expect such question in IIT where the working is little longer, but you can see the answer is like in a very simple digit. So you don't have to calculate much in these questions. So every calculation you can do it by your hand, not like using any calculation methods or calculator. Okay, hope you have understood this question. Okay, this is the question that would be found in most of the content, most of the booklets that you are solving of various institutes. Okay, so this is again a very important question. So the art was just finding out the Van't Hoff factor of this. Okay, now NaHSO4 is an ionic compound, so it will break into Na plus and HSO4 negative. Now HSO4 negative will further break into H plus and sulfate ion. This is a complete dissociation reaction. Okay, because it's an ionic compound. HSO4 negative attains an equilibrium with the sulfate ion and H plus. Okay, so we need to calculate the Van't Hoff factor for the system. So finally in the solution Na plus, HSO4 negative, H plus and sulfate ion are present. So we'll calculate the total number of particles divided by initial. Okay, so we'll get the value of Van't Hoff factor as 2 plus alpha. We knew the depression in freezing point. From that we calculated the value of alpha and then we plugged in the expression. So you can see we are using a small portion of ionic equilibrium. Okay, so that is why I already told you I started with ionic equilibrium, because there will be some formulas of salt hydrolysis, weak acid, amphiprotic substance, buffer solutions that we are going to frequently use. Okay, so if you have not seen those lectures, there are basically 6 lectures, a quick revision of all the important concept of ionic equilibrium. You can go in the catch-up videos of Master, and in the 12th class chemistry program, you can see the ionic equilibrium chapter. Okay, and I hope you have done it, because we'll need it a lot in the next chapter, which is electrochemistry. Okay, so hope you have understood this question. You can take a snapshot of this as well now. Okay, so just solve this question now. I will give you some time. Just read it and solve. So this says that there is a 75.2 gram of phenol and it is dissolved in 960 gram of solvent whose Kf was 14 Kelvin kg per mole. If the depression in freezing point is 7 Kelvin, then find the percentage of phenol that dimerizes. Okay, so we knew the mass of phenol. Okay, I'm going to write this as PHOH. Okay, since you might have done organic also, so phenol is basically written as PHOH. Okay, so the mass of this is 75.2. Okay, number of moles of phenol would be mass of phenol upon its molar mass. Okay, so phenol is basically C6H6O. So C6 means 72, 77, 78 plus 60, 94. So we'll get the number of moles of phenol. Okay, we know the mass of solvent. Solvent is having 960 gram as the mass, so it will be 0.96 kg. So we'll find the molality. Okay, this small m solvent means mass of solvent. When only small m I am writing, it means it is molality. So this would be 75.2 divided by 94 divided by 0.96. So in this way you will be able to calculate the molality of the given solution. Now we know that depression freezing point is 7 Kelvin. So we'll say that delta TF is equals to IKF into M. Okay, so delta TF I know is 7, I don't know, KF I know is 14. Okay, molality I know is 75.2 upon 94 into 0.96. So from here I will get the value of I. So this is 7 into 2 is 14. So I is 94 into 0.6 divided by 2 into 75.2. Okay, so I can write this as I as 47, just cancelling this 2 into 0.96 divided by 75.2. Okay, so if we calculate this, this will come out to be this will come out to be 0.6. So Van't Hoff factor is 0.6. Okay, now I have to find the percentage of phenol that dimerizes. Okay, so because it is dimerizing, so I will write 2-phenol is getting associated and is forming PHOH whole twice. This is the dimerization. Two molecules are coming together and joining. So at time t is equals to 0, let n be the number of moles of phenol. After say some time t, say alpha be the degree of association of. Okay, so this is the degree of association. Okay, so we would be left with n alpha, n minus n alpha. 2 moles of this is giving 1 mole of PHOH whole twice. So 1 mole will give half mole of this. So n alpha would give n alpha by 2. Okay, so total number of particles finally PHOH and this both are present. So this would be n minus n alpha plus n alpha by 2. So this would be n minus n alpha by 2. Okay, so I can write I as total number of particles finally upon initially it was n. So this I would be 1 minus alpha by 2. Okay, so we know that 1 minus alpha by 2 is having 0.6. Okay, the value of I is 0.6. So alpha by 2 would be 0.4. So alpha would be 0.8. Okay, so we'll say that it is 80% dimerized. Okay, so this can be a very important question for JEE Advanced. Okay, just few steps of calculations are required and we'll get the answer. Okay, so there was just a calculation involved over here. If you have done this calculation right, everything is very easy. Okay, generally I recommend you to do the calculation in the last step so that the margin of error is less, because if we are taking like any truncated figure over here, so that will create more error. So just calculate in the last step. Do not calculate anywhere, just have the calculation left for the last stage. Okay. Okay, hope this question is clear to you now. Okay, so there is another question. So this says that we are having a mixture of 0.1 mole of Na2O and 0.1 mole of BaO that is dissolved in 1000 gram of water. We need to calculate the vapor pressure of the solution at 373 Kelvin. Okay. So because we have to find the vapor pressure of the solution, that means we have to use the formula of relative lowering of vapor pressure. Now the vapor pressure of pure water is not given to us. Okay, because we know that the formula of relative lowering of vapor pressure is P naught minus P upon P naught into I into mole fraction of solute. Okay, but here you can see that the value of P naught is not given to you, but in the question it is written that the vapor pressure of solution at 373 Kelvin. Okay, at 373 Kelvin and 1 atm, the vapor pressure of pure water is 760, because at that point the water would start boiling. Okay, if water was pure at 760 mm of Hg or at 1 atm and 373 Kelvin, the solution start boiling. The solution will start boiling only when the vapor pressure becomes equal to the external pressure. So at that temperature of 373 Kelvin, the vapor pressure of pure water would be 760 or 1 atm. Okay, so let us say that P naught water is 1 atm at this temperature. So we need to find the value of P naught. Okay, we need to find the value of P. P naught is given now. Okay, hope this is clear to you. Now there are two solutes that we are adding. Okay, we are adding Na2O. Okay, so Na2O when we are adding, it will give 2 Na plus ion and a O2 negative. Because its degree of dissociation is not written, so we will say that it is again 100% dissociated. So Van't Hoff factor of I would be 3, because finally it is giving 3 number of particles. If you look at barium oxide, so barium oxide is giving us Ba2 plus O2 negative. Okay, so 1 mole of this is giving 2 moles of ion. Now because degree of dissociation of barium oxide is also not given, so you'll assume it to be 100% dissociated. So in solution it will give us 2 ions. Okay, now moles has been given to us. Okay, so number of moles of barium oxide is given to us. Okay, so number of moles of barium oxide, which was one solute, this was given to us as 0.1. Number of moles of Na2O, which was another solute, was also 0.1. Number of moles of solvent or water would be 1000 upon 18. Okay, this would be 55.56. Okay, so the mole fraction of barium oxide, okay, would be moles of barium oxide upon 55.56 plus 0.1 plus 0.1. Okay, moles of barium oxide upon total moles. Similarly, mole fraction of Na2O, this would be 0.1 divided by total moles. Total moles is again 55.56 plus 0.1 plus 0.1. Okay, so both of them will have same value. So you can calculate this. So this value will come out to be 1.8 into 10 raised to minus 3. So this is basically 1.8 into 10 raised to minus 3. Okay, so we knew the mole fraction of these solutes. Okay, now we know that the vapor pressure P naught minus P upon P naught was equal to mole fraction of solute. Now because there are two types of solute over here, so we'll write it as mole fraction of Na2O into its Van't Hoff factor plus mole fraction of BaO into its Van't Hoff factor. Okay, because both of them are solute now. Okay, so this would be P naught minus P upon P naught equals to, okay, so we know that the mole fraction of BaO is 1.8 into 10 raised to minus 3, okay, and its Van't Hoff factor is 2 plus, okay, mole fraction of Na2O, which is 1.8 into 10 raised to minus 3 and into its Van't Hoff factor, which is 3. Okay. So we know the value of P naught, which is 1. Okay, we will get the answer in ATM. So this is also 1. So the answer would be P would be, this is 1. So this gets multiplied. P naught minus P is equal to this. Okay, so P naught is 1. So P would be 1 minus, okay, just take 1.8 into 10 raised to minus 3 common. So this into 5. Okay, so this would be the pressure of the final solution. Okay, so 1.8 into 10 raised to our minus 3 into 5 would be 9 into 10 raised to minus 3. So we'll get the value in ATM. If you want to calculate in mm of Hg, we'll multiply this with 760. Okay, so you can see that again when two solutes are given to us, so we'll have to take both the solute. Okay, so I into mole fraction of one solute plus I into mole fraction of the other solute. Okay, hope this is clear to you. Hope you have taken a snapshot of this as well. Okay, so there is one last question. Okay, just have a look at this. So don't worry if you are facing a lot of difficulty while solving a coordination compound question, because coordination compound questions will be discussed in coordination chapter also. So that will just come in another month. So this is important. So that is again going to be discussed when we are discussing the coordination chemistry. So this says that relative decrease in vapor pressure of aqueous solution containing 2 moles of this complex in 3 moles of water is 0.5. Okay. So on reaction with AgNO3, this solution will form how many moles of AgCl? Okay. So first let us calculate, okay, because it is telling us decrease in vapor pressure. Okay. Decrease in vapor pressure of aqueous solution containing 2 moles of this in 3 moles of water is 0.5. On reaction with AgNO3, this solution will form. Okay, so this data is basically given to us to calculate the Van't Hoff factor. So we know that relative decrease in vapor pressure or the lowering in vapor pressure is P naught minus P upon P naught equals to I into mole fraction of solute. Okay, now this has been given to us as 0.5 relative decrease in vapor pressure of an aqueous solution, okay, containing these many mole is 0.5. So we know that I into mole fraction of solute is 0.5. Okay, so the mole fraction of solute would be moles of solute. Moles of solute is 2 upon total moles. Total moles is 2 plus 3 because 3 moles of water is there. So this is 5. So this is equal to 0.5. So we'll say that I is equals to 2.5 upon 2. 5 into 0.5 is 2.5. So I is 1.25. Okay, so Van't Hoff factor of this is, this complex is 1.25. Okay, I hope this is clear to everyone. Everything is written in the question. I am doing nothing over here. So this says that the moles of water is 3 and moles of solute is 2. Okay, so mole fraction of solute would be 2 by 5, 2 upon total moles. Okay, now the relative low in vapor pressure is said to be equal to 0.5. So we know that relative low in vapor pressure is I into mole fraction of solute. So from there I will get the value of I. So if we look at this complex would be breaking into CuNH3 thrice Cl plus Cl negative. Okay, so at time t is equals to 0, let us assume that N is the number of moles, because if it was 100% ionized, then the number of particles coming in the solution should be 2. Van't Hoff factor should be 2, but it is coming out to be 1.25. That means it is not 100% dissociated. So let the degree of dissociation be N, degree of dissociation be alpha, sorry. So this would become N alpha would be dissociated. So we'll be left with N minus N alpha. Now 1 mole of this complex is giving 1 mole of the cation and 1 mole of an anion. So N alpha that reacted would give us N alpha moles of this and N alpha moles of this. So the total number of particles finally would be, okay, finally these 3 particles are present. So this is N minus N alpha plus N alpha plus N alpha. Okay, so that would come out to be, if we take N common, n into 1 plus alpha. So Van't Hoff factor would be 1 plus alpha. Okay, now we know that the value of 1 plus alpha is 1.25. So alpha is 0.25. Okay, hope this is clear to you. Okay. So when we are taking 2 moles of this complex, okay, we are taking 2 moles of this complex. So 2 moles of this complex would give us 2 into alpha moles of Cl negative, okay, and the value of N is 2. So 1 mole of this is giving 1 mole of this. 2 moles of this would give N alpha because it is not 100% dissociated. So the number of moles of Cl negative formed would be is N alpha. The value of N is 2, so 2 into alpha. Now the value of alpha is 0.25. So this would be 0.5. Okay, so the number of moles of Cl negative present in the solution when this complex is dissolved in water is 0.5. Okay, so when you dissolve 2 moles of this complex, 2 moles of CuNH3Cl, Cl, okay, plus in the aqueous solution, so you will be getting 0.5 moles of Cl negative. Okay, now this Cl negative would react with AgNO3. Now we know that if we react AgNO3 or Ag plus with Cl negative, we get a precipitate of AgCl. So 1 mole of chloride ion reacts with 1 mole of Ag plus to give 1 mole of AgCl. Okay, so 0.5 mole would react with 0.5 mole of Ag plus to give us 0.5 mole of AgCl. So answer of this would be 0.5 moles. Okay, I hope this is clear to you. So this is again a very beautiful question, a very logical and a question that involves the basic knowledge of Van't Hoff factor and the coordination compound. You can expect such question to be the part of JEE Advanced. Okay, you can see these questions are not difficult. Only thing required is the basic approach and a conceptual knowledge to crack this question. Okay, IIT, as I always tell to everyone, IIT is not a difficult exam. Okay, unfortunately, like because many platforms, many institutes are there, so they are just like giving a dose in the market that it is very difficult. You need a highly competitive training for this. Okay, it can be done very easily sitting calmly at your home, following a particular lecture and doing the solving by your own. Okay, it is not a rocket science. Only thing that is required on an online platform to learn is the dedication. Okay, the self-learning approach, a disciplined approach for your studies, okay, and focusing more because at home you are not following any particular system, you are not watched by your teachers. So only thing is required is dedication from your side, a passion from your side, and advantage of sitting at a good platform where you can learn the concepts very easily and you can solve and you can give test and you can self-analyze yourself. Okay, because ultimately it boils down to the self-analysis. Everyone should have a self-analysis of their preparation. They should understand where am I lagging, what is the exact problem in my preparation, because if all the students in India do that, then preparation will become very easy. It will never be a pressurizing situation. It will never be driven through coaching institute. It will be driven only by ourselves. Okay, so you need to just be in the right company, right place and interaction with right books. Read, because that is the only way of improving your skills. You cannot improve your skills just by going to a particular institute or getting taught or getting mentored by any teacher won't give you a security of a seat in a good college. That would only come when you are sitting by your own, working hard, making you explore yourself and doing all the hard work that is required to increase your capability of thinking. Because if you are doing that, your skills will definitely improve over a period of time, which on practicing will make it more effective for cracking the examination. Okay, so I hope you have understood this question. Okay, this is a very, very beautifully crafted question and I hope that you have understood this topic. Okay, so today we have discussed a very important portion of Van't Hoff factor. Officially this chapter is over now, but I will take one more lecture because I want to show you the various kind of problems that are coming in JEE Mains as well as Advanced. So in the Monday's lecture, we will be discussing many questions that had previously come in JEE mains and few questions that have come in JEE advanced. Plus we will also solve some multiple choice question, because till now we have not solved any multiple choice question in this chapter. So I will focus on some multiple choice question, but multiple choice question is just the conclusion of the theory. So if the theory is very brisk, if you have made a very good note of your theory that has been taught to you, and if you have read a good book, then multiple choice questions are not difficult to crack. Okay, either it will be a numerical. So if you are having a subjective approach, you can easily solve those, and for theory you need to prepare your notes and then you need to read a good book. And whatever problem, whatever doubts you have, you need to post your doubts regularly so that we can we will reach to you and we'll solve those problems for you. Okay, so this is the completion of another chapter, solutions. So till now we have discussed 3 chapters: ionic equilibrium, okay, chemical kinetics and solution. On Monday we will be doing a high level problem solving or a tough level problem solving on this chapter, and we'll start with electrochemistry. So electrochemistry would be the next chapter. So we'll take roughly 15 to 20 days in completing that chapter, and in the month of June we'll start with solid state. That would take around about 2 weeks, and then we'll have the surface chemistry chapter. So by the end of June we'll be completing all the physical chemistry chapter that are there in your +2 syllabus. Only nuclear chemistry will be left. Don't worry about that. We'll discuss when we'll get the time. So after June I will start with coordination chemistry first. So July will basically go in coordination chemistry, okay, and then August we start with the organic chemistry. Okay, so I will make sure that the topics which we are doing right now should be focused on. So don't worry about the syllabus. When the syllabus will get over, we'll be able to complete the syllabus on time or not. You should focus on your constructive and a good level of solving in a given chapter. Okay, you don't need to think about various aspects. Like we are here, we will definitely assist you, and this has been our job from last 15 years. So we are doing this from last 15 years. So we know that what are the important chapters that should be taken care of first, and what are the chapters that can be finished quickly. So we are taking our time. Okay, I'm just giving you some time for understanding the conceptual approach, so that your level of solving, your level of doing the calculation increases. Okay, after completion of this chapter, because we have completed this chapter, I hope you have made a notes. Now what you have to do, okay, preparing a very good notes, and then you can solve the daily practice problem sheet which has been given to you. You can refer to NCERT exemplar as well for your solving, and then whatever book you are solving, whatever physical chemistry books which you are following for your JEE preparation, you can solve that, or the content of the institute, you can also solve that. Okay, so I hope you are enjoying sessions with us. I hope you are liking the lectures. Okay, this is the first time that I have gone online. I am catering to so many students. So your quick feedback would be required, so that I am able to adjust the level of the lectures accordingly and give you the best curated content that is available on any of the platform.